The second part of 7.3 is about raising a fraction. So once you find an LCD, which we talked about how to find an LCD, then you might be saying, well, what's the purpose of me finding an LCD? The purpose of finding an LCD is that we know that with addition and subtraction problems, we have to make these denominators the same before we can do any subtraction in our case. So we already talked about how to find the LCD here when it's a 3 and a 9. We told you to do either the multiples table, which we've learned in probably like Math 075, or 055, or the factored form, which we told you 9, if you factor that out, is 3 times 3, and then that means 1 3 versus 2 3s, we need 2 of them, 3 squared is 9. So we showed you how to find the LCD of 9. The question is, okay, now that you got the 9, what do you need to do? When it comes to addition and subtraction, you need to have the denominators the same. So how do we do that? Notice this denominator is a 3. We can raise it to the LCD. So take the 2/3 and put your common denominator here. What we want to do is take these two denominators and see if we can factor them out completely. Because here's our steps. Step 1 is to make sure the LCD and the denominator is in factored form. The second step is then I'm going to draw a box in the numerator and a box in the denominator. Because when I compare the two denominators, the LCD and the original denominator, what you want to do is want to see what are the extra pieces. Those extra factors will go into the box, and then you multiply the top box with the numerator to find your equivalent fraction. So this is factored form. This 9 is not in factored form. The factored form of 9 was 3 3. Remember, 3 squared, 2 3s. Now that the both denominators are in factored form, have a box at the bottom and a box on top. These boxes have to have the same values at the bottom and on the top. The reason why is because if you multiply any fraction by 1, you haven't really messed up the fraction. You actually just kept it the same, that they're equivalent. But these have to be the same boxes. So what you're going to do is compare these two denominators to see who's your hitchhiker, who's that extra piece. I tell people a lot of times a little story, and I always would say, pretend that you're a bus driver. You originally have just one passenger, 3. So you left Philadelphia with one passenger, 3, and then the time that you got to Boston, notice you got 2 passengers. Wherever your extra passenger, your extra piece, goes into this bottom box. So this one is here, but somewhere around the route, you picked up an extra 3. That goes here. Whatever's in the bottom box, that extra piece, has to be the same on the top. So now that we know the extra piece, when you compare here to here was an extra 3, we can put 3 here and 3 here. 3 divided by 3 is 1, so this is basically not changing the fraction. 2/3 times 1 is still be equivalent. What you want to do next is now multiply the top to get your new top. 2 times 3 is 6. Now I know a lot of you probably were looking at this 2/3 and knew that 6/9 would be the equivalent. But again, we're doing these little steps because we're not going to have just plain numbers. So this, the equivalent of 2/3 would be 6/9, which then makes it easy for us to subtract 5/9. Because we told you fractions, when you do subtraction or addition, have to have the same denominator. Size 9, good to go. So then you just subtract the tops. 6 minus 5, we know is 1. Keep that same matching denominator. 9, 9, 9, stays 9. You never subtract the denominators. Don't do 9 minus 9 is 0. Okay, 9, 9, 9, 9 across the board. So now that we know how to raise a fraction 2/3 to find its equivalent is 6/9, how do we do this when we have rational expressions with letters? Well, let's show you. We'll do our first question with monomials, and then we'll do the other one as binomial. So let's say we had this as one rational expression. Remember, it has letters, so it's rational expression. And this is your LCD. So let's say we found our LCD to be that. How do we raise this to become the equivalent? Well, again, the first step. If it's not already in factored form, put it in factored form. When you do this method, make sure that if you have a factored form and the original form, use the factored form. So 28x squared, I don't have a factored form, so let's put it in factored form. Remember, if it's one term, you know you could do a tree diagram. So break down 28x squared. You know that's going to be 2 times 2 times 7 times x times x. Hopefully you knew 2 times 14. 14 is 2 times 7. Let's break down 56 x cubed y squared. Maybe 56 might be a little harder for you. So if you need to do a real tree diagram, 8 times 7 maybe, and then 8 is 2 times 4, and 2 and 2. So hopefully you know that 56 is 2 times 2 times 2 times 7, remember 3 2's and a 7, and then 3 x's, oops, and then 2 y's. So now that we have this and this, the factored forms, don't look at the original. Look at the factored forms. Okay? So that's step 1. Make sure the LCD in the denominator is in factored form. Then what we're going to do is draw the box in the numerator and in the denominator. Okay? So I have a box here, and I have a box here. What I'm trying to do is trying to figure out what's the extra piece. Remember, you're a bus driver, you're in Philadelphia, these are your passengers. 2 2's, a 7, and 2 x's. But when you got to the very end in Boston, notice that you have 3 2's. You have a 7, you have 3 x's, and you have y's. So you can see that you had 1, 2, 3, 4, 5 passengers, but when you got here, 1, 2, 3, 4, 5, 6, 7, 8, 9 passengers. So figure out what your extra parts were. So you can see that if I had 2 2's, but now 3 2's, that's extra. The 7 and 7 match, okay? 2 x's, but now 3 x's, so one of them is an extra piece. And you didn't have any y's, and now all of a sudden you have 2 y's. So your extra pieces are 2, x, y, y. Those extra pieces, you're going to put in the bottom box. Because if I took this 28x squared, or this one, and multiplied with this box, I'll get this 56x cubed y squared. Remember, 2 x's plus 1 more x is 3 of them. No y's, and then another 2 gives me the 2. And then 28 times 2 is 56. Whatever I do to the bottom, you might have heard, you have to do to the top. So that's why I always said whatever's in this bottom box has to be the same on the top box. Because if they're not matching, then you're not actually multiplying by a factor of 1. So if I multiply the bottom by this box, now I have to multiply the top. So 3 times 2 times x times y times y. 3 times 2 is 6. X. Y, we can write it out as y squared. Now what I want you to realize is do not cancel. Do not say y squared over y squared. Because if you start canceling, you're going to get this original. Our goal is to take a fraction and pump it up to be a larger equivalent. The reason why is because when we get to addition and subtraction, we might need this pumped up one to do our problem of addition or subtraction. So don't try to reduce when you find an equivalence. Leave it alone, do your addition and subtraction, then you can start reducing. So for this answer, to have an equivalent fraction to the original 3, 28x squared, would be 6xy squared over that LCD that we told you. So if I was looking for the equivalence, that would be your final answer.